The Sun is a very turbulent, violent, and ever-changing star. The Sun can act like a cosmic shotgun, blasting billions of tons of charged material out into the solar system. These events can have a profound effect on our environment here on Earth. Take, for example, an event that occurred on March 14, 1989. At 2:45 a.m., power was cut off to 6 million people living in eastern Canada for 9 hours. This blackout was caused by an explosive event on the Sun called a coronal mass ejection. This particular coronal mass ejection blasted billions of tons of electrically charged particles directly at Earth, inducing huge electrical charges. This electrical activity can damage our power distribution systems. When the Sun blasts this plasma into space, it rockets at speeds greater than 450 kilometers per second. That's more than 1,000,000 miles per hour. It's traveling so fast that it takes about 3 days for this plasma to reach Earth. And this stuff isn't lightweight. Several billion tons of plasma are shot out in these explosions. The good news is that as this material races through space, it spreads out, and by the time it reaches Earth, only a fraction of the Sun's plasma impacts the Earth's magnetosphere. As these charged particles rain into the ionosphere and upper atmosphere above the poles, they release tremendous amounts of energy as they react with the gases in the Earth's atmosphere. This chemical reaction gives those living in northern and southern latitudes an eerie light show called the aurora borealis or aurora australis. But as we mentioned earlier, these particles have effects that aren't so beautiful. When the Earth's magnetic field is pushed and pulled by this onslaught of solar plasma, it creates huge power fluctuations. These fluctuations can affect power lines, overloading and damaging power transformers, tripping circuit breakers, and causing anything from flickering lights to widespread and potentially dangerous power outages. Solar storms also interfere with television and telephone signals, airplane and ship navigation. And solar storms can cause pipelines to corrode much faster than normal. And as the magnetosphere gets pushed and pulled by the impact of solar plasma, massive electrical charges are generated in space, where satellites orbit the Earth. This can cause a huge electrical charge to build up on the outer surface of satellites. It's very much like static electricity. If this electrical charge discharges inside the satellite, it can cripple or destroy it. And what about the men and women astronauts working in space, outside the protective cover of the space shuttle and the space station? They could be in grave danger if caught unaware by a solar storm. Not only must astronauts be concerned about the buildup of electrical charges, but solar storms bring a lot of harmful radiation with them. We have a lot to learn, but what we've discovered so far is very exciting. We know, for example, the Sun has an 11-year cycle. The number of storms on the Sun increase and decrease during this cycle. At what scientists call solar minimum, the Sun is relatively quiet. There are few storms and few sunspots. As the Sun approaches its active peak, called the solar maximum, solar activity increases. At solar maximum, there are more sunspots, more storms, and more flares. It's here at solar maximum that our chances of being hit by a coronal mass ejection increase dramatically. Now that we are well on our way to the next solar maximum, with more satellites and a greater reliance on technology than ever before, what can we do? Just as mankind is unable to control hurricanes, we are equally powerless against the solar storms sent our way by the Sun. We can, however, strive to predict, track, and prepare for these onslaughts